There's this picture we all have in our heads when we see a kid learning to talk. We see them just, listening, repeating words, and we think, okay, it's a giant copy-paste job.
Right. They hear stuff, they say stuff back. It's the most intuitive view in the world.
It's what people call the experience-dependent model.
Yeah.
Right? Language is just like learning chess or cooking.
Exactly. You watch, you find patterns in the data, you get better. Simple.
But the source we're digging into today argues that that whole picture is, well, just completely wrong.
Fundamentally wrong, yeah.
We're doing a deep dive into some work by Stephen Crane and Rosalind Thornton, specifically on syntax and semantics, and they make this really bold claim.
It's aggressive.
That if kids were actually learning language just by listening to us, just by crunching the numbers on the data, they'd fail.
Oh, they would fail spectacularly.
Yeah.
Crane and Thornton are coming from the nativist side. This is the idea, that the brain isn't a blank slate.
It comes preloaded with something.
It comes preloaded with a universal grammar. Think of it like the BIOS on a computer. It's the foundational system that defines what's even possible in a human language, and it's there before a child ever hears a single word.
So our mission for this deep dive is to really stress test that idea. We're going to look at the specific, and I have to say, pretty weird evidence they bring up.
Oh, it gets weird.
We're talking Ninja Turtles, invisible ghost words, stuff like that.
But it all ties back to one central concept, which they call the poverty of the stimulus.
Which is just a fancy way of saying the data kids hear is bad.
It's not just bad, it's insufficient. The input from parents is, it's too messy, it's too limited, it's full of mistakes. It can't possibly explain the complex, rock-solid rules that kids just know.
Okay, let's make that concrete. Let's start with something that feels super simple. Yes, no questions.
Right.
If I have a sentence, say, Bill can play the sax, and I want to make it a question, the rule seems obvious. I just take can and move it to the front. Can Bill play the sax?
Yep. If you were coding a basic AI, you'd tell it. Find the first little verb, move it to the front. A simple linear rule.
But then the text throws a wrench in it. They use a trickier sentence. The farmer who is beating a donkey is mean.
A little violent for a grammar example, but it works.
So if I use that same simple rule, move the first verb, I grab the first is, I see, and I get. Is the farmer who beating a donkey is mean?
Which is just total gibberish.
Complete nonsense. The right way to say it is the farmer who is beating a donkey mean?
Exactly. So to get that right, you had to ignore the first is and grab the second one. But why?
It's about the structure, not the order.
It's all about structure. That first is buried inside that little descriptive phrase, the who is beating a donkey part. The rule isn't move the first verb, it's move the verb from the main part of the sentence.
They call this structure dependence. But, couldn't a kid just figure that out? They hear enough sentences, they try it, it sounds wrong, they try something else. Trial and error.
You would think so. But this is the poverty of the stimulus kicking in. The authors point to this study by Leggett and Yang, who went through these massive databases of parents talking to their kids.
So real-world data.
Real-world data. They wanted to see how many times kids actually hear one of these complex "is the farmer who" type questions.
Yeah. Both the number.
It's basically zero. For one child, Nina, they looked at over 20,000 questions. Only 14 had this structure. Another child, Adam, 4 out of 8,000.
4. That's nothing. That's a rounding error.
It is nothing. So if a kid is learning from the data, they don't have enough examples. They should be making this mistake all the time. They should try the simple rule first, right? Move the first verb.
But they don't do it.
They almost never do. Kids just don't make that specific mistake.
So if they don't hear the rule and they don't mess it up,
then they must already know it. They are born knowing that language is about structure. It's like a built-in constraint. It's part of the hardware.
Speaking of constraints, the text then shifts from things you have to do to things you absolutely cannot do. This is where the Ninja Turtles make an appearance.
Right. This is all about reference, how we know who a word like he is pointing to.
Okay, so they set up this experiment with a Ninja Turtle. Let's take 2 sentences. Sentence A. The Ninja Turtle danced while he ate pizza.
Mm-hmm.
In that sentence, he can be the Ninja Turtle, right? That's obvious.
Of course. The turtle is dancing and eating.
Okay, now sentence B. He danced while the Ninja Turtle ate pizza. In this one, can he be the Ninja Turtle?
No, absolutely not. In that specific structure, he has to be someone else. Maybe Shredder's dancing in the corner, but he cannot be the turtle.
To me, as an adult, that feels instinctive. But how does a kid learn that? Parents aren't going around saying, Now listen to me. A pronoun cannot refer to a noun that comes after it if the pronoun is in the main clause.
Right. No one ever gives kids what's called negative evidence. Parents correct for truth. If kid says, "Heard eat a crayon," the parent says, "We don't eat crayons." They don't give a grammar lesson.
So a kid never gets told what is impossible.
And yet, this study by Crane and McKee that they cite shows that kids as young as 2 and 3, they get this. They consistently know that he can't be the turtle in that second sentence.
How? If you can't learn a don't from a bunch of do's.
It has to be part of the blueprint. The constraint is already there.
These rules are so invisible, we just follow them without thinking. And there's another one in the text about contracting want to into wanna that really blew my mind.
The wanna contraction. This is, I think, one of the most powerful arguments for the nativist side. It involves something linguists call a trace.
Okay, hold on. Let's define that. What is a trace?
A trace is basically, it's a ghost. When you move a word to form a question, the theory says it leaves behind an invisible, silent placeholder where it used to be. You can't hear it, but your brain's grammar processor sees it.
Okay, a ghost word. So let's see it in action.
Right.
I want to say, I want to go. I can squish that into, I want to go.
Easy enough. Now, take a question. Who do you want to kiss?
Okay.
The underlying structure of that is you want to kiss who. To ask the question, you move who to the front. So the trace, the ghost, is left at the very end.
After the word kiss.
Right, so there's nothing standing between want and to. They're next to each other. They can merge. Who do you want to kiss? Perfectly fine.
Got it. Now, here's the tricky one from the text. Who do you want to make breakfast? And the context is, I'm asking you to choose who's going to be the cook.
Okay, so the underlying thought is you want who to make breakfast. The who starts out right in the middle, between want and to.
So when I move who to the front to ask the question.
It leaves its ghost right there.
Yeah.
A trace is sitting between want and to, and it acts like a little invisible wall. It blocks them from contracting.
So I can't say, who do you want to make breakfast? If I'm asking who should cook.
Exactly. If you say, who do you want to make breakfast? It sounds like you're asking a totally different question, like, who here feels like making breakfast? It changes the meaning.
And kids get this. They respect this inverbal ghost wall.
They do. They use wanna all the time. It's a huge part of their vocabulary, but they almost never use it in that one specific forbidden spot where a trace is blocking it. And again, you have to ask yourself, how could a 3-year-old learn that?
Yeah. How could you figure that out from the data?
Yeah.
It's nuts. It implies their brain is doing some kind of, subconscious algebra while they're asking for juice.
That's a great way to put it. Subconscious computation.
Okay, I want to shift gears a little bit. The second half of the source moves away from pure grammar and into logic. And this part got a little dense, but the claim is fascinating. They argue that, in some ways, kids are actually more logical than adults.
This is the whole or versus and thing. It's where linguistics bumps right up against formal logic.
Right. So in everyday speech, if I say, do you want coffee or tea, that or means pick one, not both.
It's exclusive, yeah.
But the text says that in formal logic and in a child's mind, or can sometimes mean and.
Specifically under negation, in negative sentences.
Yeah.
So take their example. The girl who stayed up late will not get a dime or a jewel.
Okay.
So does she get the dime?
Yeah.
Does she get the jewel?
No.
So she gets not a dime and not a jewel. The or just behaved logically like an and.
I see that. But then they connect this to the word any. This is where they bring in this concept of downward entailment. Can you unpack that a bit?
I'll try. So downward entailment is basically a name for a special kind of logic zone in a sentence. It's usually created by a negative word like not or a phrase like if. And inside this zone, logic kind of works differently.
Okay.
The authors point out that the word any is what's called a negative polarity item. It's picky. It only likes to live inside these special negative zones.
Give me an example of that.
You can say, I didn't see any students. It works because didn't creates that negative zone. But you can't say, I saw any students.
Right, that just sounds wrong to my ear.
Now, here's the amazing part. The connection. The exact same zones where any is allowed to live are the exact same zones where or logically transforms into and.
So, a child isn't learning two separate random lists of rules, one for the word any and another for the word or.
That's the nativist argument. No. The child has an innate understanding of this deeper logical environment, this downward entailment. They know this one property of a sentence connects both of those things.
Whereas the other view, the experience view, would mean the kid has to figure out these two totally separate, weird quirks of English.
Right, which would be massively inefficient. The fact that these things are linked and that kids get them so early suggests they're tapping into a deep core logical system.
Which leads right into the continuity hypothesis, which I thought was maybe the most compelling idea in the whole piece.
Well, it's a great concept.
The argument is basically, when kids make what we call mistakes, they're not actually breaking the rules of language. They might just be speaking perfect Italian.
Or perfect Japanese, yeah. The idea is that universal grammar is like a big menu of options, switches you can flip. And learning your specific language is just about flipping the switches to match your local community.
And the example they use is an English-speaking kid who asks why you are here instead of why are you here.
Mm-hmm. They don't do the inversion.
To us, that sounds like a mistake. Broken English.
But in Italian or German, that structure is perfectly grammatical. The child isn't wrong. They're just using a setting from the universal menu that English doesn't happen to use in this case. They haven't flipped the English inversion switch yet.
And the example with Japanese children was even more incredible because it goes back to that logical or we were just talking about.
Yes. This is a case where the child is more logical than the adults around them. In adult Japanese, for reasons of politeness, speakers often avoid that strict logical reading of or in negative sentences.
So the kid isn't hearing that neither nor logic from their parents.
No, the input they get is actually less logical, it's more ambiguous. But when you test Japanese toddlers, they default to the strict logic. They interpret not A or B as neither A nor B, following De Morgan's laws.
So they are literally ignoring what their parents are saying and defaulting to the universal blueprint.
Exactly. If they were just copy-pasting, they'd be ambiguous like the adults. But they're not. They start out as perfect little logicians until the culture teaches them to be less direct.
That feels like a huge problem for you, just copy what you hear theory?
It's a massive problem.
One last piece of evidence from the text. It's about hidden meanings and the word only.
Ah, yes, the contrast set.
The sentence is, only Bruce speaks French. This sentence really means two things, doesn't it?
It does. Part 1 is positive, Bruce speaks French, but part 2 is a hidden negative. Everyone else does not speak French.
And the research shows that kids just, get this, they compute that hidden negative part instantly.
Effortlessly. And again, the argument is, how could you learn to calculate a hidden negative meaning just from statistical patterns? It suggests a built-in mechanism that understands how a word like only functions logically.
So let's zoom out. We started this whole deep dive with this question. Is language just a cut and paste job? And when you stack up all this evidence, the lack of complex questions in the data, these invisible traces,
The innate logic that sometimes even ignores what parents are saying.
that data-driven model starts to look really, really shaky. It basically requires a child to be a supercomputer, deriving complex rules from hearing almost nothing.
The nativist model just says the machine is already built, the world just turns the key.
It really reframes the child, doesn't it? Not as this empty cup being filled up, but as a high-performance engine just waiting to be started.
And it suggests that the deep structure of language, and maybe even thought itself, is universal.
And that's really the thought that sticks with me. If a kid in Tokyo and a kid in Ohio both start with the same logical toolkit, despite hearing completely different sounds, are we all just speaking the same mental language underneath it all?
It suggests we're all running the same OS, we just have different language packs installed on top.
A pretty humbling thought. Thanks for joining us for this deep dive into the blueprint of language.
It was a pleasure.
And for you listening, the next time you hear a toddler stumble over a sentence, just ask yourself, are they making a mistake? Or are they just speaking a dialect of a language that's common to all of us? We'll see you next time.